Greetings, this is Mr. Glenn of ACT Prep Chicago, doing another video for you. This one will be the science section of the ACT Online Digital Exam 1, which is the same as the PDF version. I actually prefer to do the science with PDF, but I think I'll still just do the digital way just because that's the way most of you guys will be testing from henceforth. So without further ado, let's get started. So this is where I get it from, the test from the official ACT's official website. Um, yeah, so it's you go to free ACT practice test, and then you would go to and just click, then you go to online practice test, and that's how you get to here. And then online practice tests are here. Um, We're going to do the science today. We're going to do it on time because I'm going to be explaining. It opens up a different window. Um, if you also, you can access it via the PDFs. So when you click on that test prep and it says free practice test and prep, if you scroll down, you'll see it says download practice test one, preparing for the ACT. These are the exact same questions as also in the online practice, which is this link here, which is what we'll be working with. So just to show you too, if we open up this test, well, it's here. I opened up already, preparing for the ACT book one. Let's just go to science since we're doing that now. This is the PDF. I like the PDF version better for doing science. I think I might just do PDF because you don't use a calculator on the science or the digital version anyway. But well, this is well, I do it because most of you guys are gonna be probably doing the online version, but this is the online version. So if you see question one, she says based on table two, which is the following ratios best represents the number of times behavior two is displayed in habitat X compared to the number of times behavior two is displayed in habitat Y. If you go to the PDF, you will see the same thing. Based on table two, which the following ratios best represents the number of times behavior two is displayed in habitat X compared to number two behavior two is displayed in habitat Y. The reason I like the PDF version better is because you see I can see all of this, whereas in the digital version, I got to do a lot of scrolling. So I can see it all on one page versus up and down. But anyway, we'll do it on this one. Okay, so it says based on table two. So I look do a lot of bits and pieces. So let's find table two first. Table two is here. Which of the following ratios best represents the number of times behavior two is displayed in habitat X? Habitat X behavior two is three, compared to the number of times behavior two is displayed in habitat Y. That would be 3 to 6, which would be 1 and 2. That would be A. That's a 3 to 6 ratio, 3 times for behavior 2 habitat X, 6 times for behavior Y behavior 2 habitat Y. So that's 3 to 6, which is as a fraction reduces to 1/2. Which of the following observations for brown anoles were the same in both? Oh, a note. I don't go straight to I don't read this or annotate. Some people say read it, annotate. I don't. It's a waste of time. You should go straight to the questions for the science section. Other sections may be different, like the reading. I don't do that with the English kind of, but I read the whole sentence first. But science, go straight to the questions. Which of the following observations for brown anoles was or were the same in both habitats Y and Z? Average perching height, the number of times behavior 4 displayed, average display time for behavior 5. So what are we looking at? What's the keyword? Brown anoles. Um, the same in Y and Z, habitat Y, habitat Z. Average piercing height. So this is average piercing height for the brown, which is a circle, was the same for Y and Z. Yes, it was the same. Both were 0.6. So average piercing height. So we know it's not B. So if you want to use your tools, answer eliminator, we know B is not right. because one has to be an answer, and we know D is not right. The question is two the number of times behavior four was displayed? The number of times behavior four was displayed. No, the number of times displayed in Y was five, and in Z it was 17. That's also not the same. So the answer is A. All right. Um, Based on table three, let's take a look at table three. Now, this is one good thing about doing it online digital is you can actually use these to if you do the answer eliminator, if you click on it, it will allow you to get rid of wrong answers. Yeah. Let's just take a look at some of these two. Oh, the magnifier. And we move it around? Or we just put it where we want it? How does the magnifier work? I don't know how it works. I don't know who did it, but they really should go over how that will work for somebody who needs it. Well, I don't need it, so I'm not gonna waste time. I guess that's somebody who have visual problems. Um, Answer masking. What is that? Oh, so you could cover up all your answers and then just display them as you want. Why would I want to do that? Hmm. I guess that way you could go find the right answer. You won't be distracted by the wrong ones. That's probably what they're doing. But no, I want to see my answers. No thanks. Line reader. I don't know what that does. Oh, okay. So you could zero in on certain things. I guess you could focus on those. It increases your focus. No, we don't want the line reader. I don't know how to work the magnifier. Maybe it's the same way. Okay. To zoom to see better. The magnifier makes content bigger, so it's easy to move the magnifier. Use your mouse on or arrow keys to move the magnifier around and see the different parts of the content. Resize the magnifier. Click and drag the button on the bottom right. Want to make the magnifier bigger or smaller, you can use the arrow to move the magnifier. Oh, okay, so we can move all around this thing. How do we get to the bottom of table three? I guess it only magnifies it to the top. All right, anyway, let's keep on. Based on table three, how many display times were measured for behavior five in habitat Z? Have display time. How many display times? So the average. Average doesn't tell us how many display times. It just when you add them all up and you divide. So we don't know. Table two lists the number of times each behavior is displayed. There's one player on the display for only. Yeah, we can't determine that because um yeah, we just can't determine it because average means you add them all up and divide. And in table three, they give you the average display time for behaviors, five. So if it's the average, we don't know how many display times were measured, right? We just know the average. And I was looking here to see if they gave it in words and they didn't. We could check that one too. What number is that? That's number three, item three. You look up here, it tells you what question you're on your item three. And it would be D. So because I got the preparing for the ACT pulled up, you can see that question three is the same, right? And this one has the answer key. So you can almost have the answer key while you look. When you know how to access to both PDFs. I don't necessarily suggest this, but I'm doing it just because I'm just showing you how to do stuff. So if you want to test it on your own, you want to do that. Yeah, three is D. Yeah, I just thought so, but I just wanted to make sure. Okay. Based on number four, based on figure one, there's figure one here. For green anomalies, that's the squares. You see, I read a little bit, go look. The difference in average piercing height between habitat X and habitat Y was close to which found so different. So 1.6 minus that's 0.9, that would be 0.7. Yeah, that would be so question. I got the answer eliminated there. I don't really need these for some of these though, because I'm going straight to the answers. I guess it could be there just in case I need it. A student claimed that anodes were endotherms. Which of the following explains why this claim is incorrect? Um, amphibians, amphibians primarily generate heat. That should be can. This is a typo. Amphibians can primarily generate heat from internal metabolic process to maintain. Oh, no, anoles, that's not typo. Anoles are amphibians and primarily generate heat from internal metabolic processes. Anoles are amphibians and primarily absorb heat from the surrounding environment. Uh, reptiles are Anoles are reptiles and primarily generate heat from internal metabolic processes. Anoles are reptiles and primarily absorb heat from surrounding environment to maintain body temperature. Well, one thing I can tell you is that um, if I can't remember endotherms, but I think endotherms get their heat. Hmm. So this one requires background information. So first, I know there's amphibians, which are frogs, or are they reptiles? It says green aneles and brown aneles, two species of reptile, so it's right there. So we know we can eliminate what? A and B, because we know they're reptiles. Now, how do reptiles get their heat? So I don't know what endotherms are. I know that reptiles don't get their heat primarily from internal metabolic processes to maintain body temperature. They primarily get their heat from external, which is why um, reptiles can only survive in like tropical or warm climates. When it gets cold, they have a tough time. Let me make sure that's right. That was number five. Yeah, five is D. Yeah. So that require outside information. They don't tell you how reptiles generate heat. So you would need to know that. Let's see. Let me just scroll and see if they did habitat species note. They didn't tell you. Yeah, you just have to know that. That's what I thought. They don't tell you. Or they tell you that they lizards and know these lizards. Okay. And then you saw them a little fine print. All right. This one is a conflicting viewpoints passage. Now, typically I'll tell students they may want to skip this one depending on the topic, but since we're just doing an answer explanation, we'll just keep doing it. But I don't do questions first with this one. I always read first because there are no charts and tables to go off of, so it's information. It's like a reading passage within the science section. Okay. The coastline of Antarctica consists of many ice shelves. Okay, what are ice shelves? Floating 100, 1,000 meter thick sheets of ice that extend from a land mass. So you got these thick sheets that extend from the land mass and they call ice shelves. So it's almost like you'll see those, and sometimes when it gets cold in certain environments, you can go walk on what's usually a lake. I'm from Chicago, so Lake Michigan, sometimes when the water freezes, people will go walk on the ice so they can feel like they're walking in a lake, place they couldn't walk in the summer because it's water, right? So, but Antarctica has many of these things. Many of these ice shelves are melting, causing them to calve, break off large pieces known as icebergs. For students explain For students, each explain iceberg calving, which is breaking off the landmass. So that, this I get. So I might do this. I might not skip it. But this is fairly simple to me. Antarctic ice shelves melt due to the warming of the air above the surface of the ice, like maybe the sun, I'm sorry. When the air temperature increases, the surface ice melts and water pools. Water moves downward into the ice shelf, causing fractures to form. The accumulation of many fractures in the ice over many summers gradually leads to icebergs calving from an ice sheet or breaking off. That seems like the most plausible, right? Now, you learn from student two more about student one sometimes. Student one is correct that an increase in air temperature during the summer leads to surface ice melting and water pooling, causing fractures. However, the action, so this is where student two differs from one, the action of the meltwater alone is insufficient to produce fractures deep enough to cause calving. When the air temperature lowers at the beginning of winter, falling snow accumulates in the fractures. increasing the pressure on the ice, eventually causing calving. After a large snowfall, calving can occur within a few days. So that's the difference. They're saying that the meltwater alone is insufficient. So um, it's the meltwater causes some fractures, and then the snow, when it snows, gets caught in these cracks caused by some of the fractures from the meltwater, or the raising temperature of the surface will cause these big cracks, right? Um, Student three says Antarctic ice shelves melt only from below. Okay, so student three is different from one and two. One and two says it's the air temperature above that causes the melting and then the snow falling through the cracks of student two. Student three says no, it's the heat from below. During the summer, ocean currents circulate water that is just above freezing into and out of the basal cavity, the area underneath an ice shelf, causing the ice within the cavity to melt. For every 1 degree Celsius that the ocean water is above freezing, the water melts a thickness of 10 meters of ice from the bottom per year. When the ice shelf thickness has been reduced by at least 50 meters, calving occurs. So heat from below, warming the basal cavity, the water below the ice. And then fourth, the warmer water circulated by ocean currents melts the ice shelf as described by student three. The warmer water circulated by ocean currents melts the ice shelf as described by. So student four agrees with three, but it's going to be something different. However, calving cannot occur from this process alone. So it's kind of like student two. Snow accumulates on the surface of the ice each winter, but each following summer, warm air leads to the melting and compaction of the snow. So snow accumulates on the surface of the ice each winter. But each following summer, warm air leads to the melting and compaction of the snow. The compaction lowers the surface of the ice shelf, pushing the ice down into the basal cavity, where it is melted by the ocean water. Oh, after several winter-summer cycles, the ice shelf becomes top-heavy due to the snow, and the melting from below and calving occurs. All right, interesting. All right, which now we got what we got. This is I understood this pretty decent. Which of the following diagrams best shows the location of the basal cavity as described by student three? The basal cavity they said was underneath the ice. So definitely not this one. The basal cavity is not above the ice shelf, and it's not on top of the water. It was below. They said it's below the ice shelf, I thought. The area underneath an ice shelf, right? Not underneath the iceberg, underneath the ice shelf, says A. Suppose that the air temperature along the Antarctic coastline is never warmer than -10 degrees, and that the atmospheric pressure is always 1 atmosphere. Does this information support the description given by student one? No, because it cannot melt at those temperatures, right? Because the freezing point of water is 0 degrees Celsius. You got no background information, right? So if the coastline is never warmer than -2 degrees, then you won't have melting, right? So this is one that requires that you know the melting and freezing point of ice. If ice turns from it freezes at 0, but if you go above 0, it turns to liquid, right? So if it never gets above -10, it never gets to 0, therefore it will stay as ice. And student one says that it's the warm air around melts the ice, but that couldn't happen because -10 degrees would not allow for ice to melt. Based on the description of the icebergs that are calved along the coastline of Antarctica, do the icebergs sink or float? Based on the description of the icebergs that are capped along the coastline of Antarctica, what's the description? Many ice shelves floating 100 to 100-meter thick sheets of ice extend from a landmass. Many of these shelves are melting. They are what? They will sink. They are less dense, more dense than ocean water. Icebergs that are capped along the coastline. Where are the icebergs? These are ice shelves. Four students each explain iceberg halving. Oh, so iceberg is, yeah, I don't know if this is denser than ocean water. Well, here's what I do know. Icebergs usually float in water, so that means they would have to be less dense than the water. I'm gonna choose D. So here again, there's not a lot of them, but this requires background information. Icebergs are floating ice in water. If they're floating, that means it has to be float, they don't sink. And if they are floating, they have to be less dense than water. If they were more dense than water, they would sink. Now let's check the answer. Number eight is J. I was correct with that one. So a couple of them we needed were outside of J is the same as D, by the way. The digital version doesn't change the letters on this. It's just A, B, C, D, A, B, C, D. But when you do the paper version, it goes A, B, C, D, then it goes, uh, you'll see in a minute. Let me just show you. And you see it goes A, B, C, D for 35, then E, F, G, H, J for 36, and then A, B, C, D for 37, and so forth. So and J is basically the same as D is what I want to get at because we're using the answer key from the PDF. Same questions, by the way. Let's go. Okay. We did that. All right. Which of students went in for if either implied that the processes involved in iceberg calving would take more than 1 year to result in the information on the iceberg? Well, I know student four said it was to take multiple years. After several winter warm cycles, winter summer cycles, that's multiple years. A winter summer cycle is 1 year, but several of them, that's multiple years. The fact that the process involved in iceberg would take more than 1 year. So we know it's not student one only because student four is included. We know it's not neither student one nor student four because student four did say it. So did student one say it would take longer than a year? I think it did. I said maybe the one in the air service, then when the air temperature, let's look at time. We're looking for time. The accumulation of many fractures in the ice over many summers gradually leads to, so many summers is many years. That means one and four both indicate it will be more than 1 year. In regard to the seasons involved in iceberg calving, how does student two's description differ from student three's description? In regards to the seasons, student two indicated that summer and winter are involved in calving, whereas student three indicated only summer is involved. So student two says it's the air temperature and the snow. So summer and winter are involved. So student two says summer and winter involved. So ice do melt due to warming of the air. Whoops. Student one's correct that an increase in air temperature during the summer, but then you got the winter as well. They talked about that. So student two indicated, I'm reading from here, student two indicated that summer and winter are involved. We know that. So that's C and D gone because C and D would be saying student two indicate that only summer is involved. Whenever you see a question and then it starts to get answered in colon, you have to read this part with every answer choice for it to make sense. So student two indicated that only summer is involved. No. Student two indicated that summer and winter. Only winter? No. Student two indicated both. So that's why C and D are gone. So now we got to look at student three. Did student three indicate that only summer was involved and that only winter is involved? I think student three indicated only summer was involved. The warming of the water below causes the fractures. Right, just above freezing. Right, that's what they say. The water melts, right? Right. So it's just that one. Very good. Which of students two, three, and four agree with student one that some form of melting occurs on the ice shelf surface? Student two definitely does. Um, I think I know student two said it because student two said it was from the outside. It was the warm. They said during the summer leads to surface ice melting. Right. So student two said it, but I know student three says it's from the warm. No, this is from the bottom. So student three is definitely not included. Boom, boom. What about four? Having, it's warming water, yeah. However, calving cannot occur. Snow accumulates on the surface, but each following summer, warm air leads to the melting and compaction of the snow. This says student that some form of melting occurs on the ice shelf surface. They did say melting by the ocean, that it is melting. But warm air leads to the melting and compaction of the snow that's on the surface of the ice. It would be student two and four. Ice shelf becomes top heavy. It's not the ice isn't melting, no, it was the snow that's melting that pushes it down. This says that some form of melting occurs on the ice shelf surface. Yes. Four is not the ice, and four, two is the ice, four is the snow melting, but that's still some form of melting. Let's just check 11. Yes, let's see. All right, 12. Okay, so now we're on to a new passage. So we go straight to question. What are the following statements about the relationship between the number of A per cooler per tank and the average SGR is consistent with the results of experiment two? Experiment two. Relationship between, where's experiment two? Here. Relationship between the number of A per cooler per tank and the average SGR. This is average SGR. We don't know how many per tank. On average, as the number of A per cooler per tank increase, stocking density, or fish per liter, that's how many. So as this is the number increasing, the average SCR did what? It decreased. As the number of A per kilo per tank, that's the number of fish per liter, that's here. Increase going down. The average SGR, which is here, decreased. It went down. The following table gives the percent protein in each of the four diets. Percent protein in each diet. Which of the following statements about the percent protein in each diet and the average HDR is consistent with the data shown in the table and the results of experiment one? So here's a table. Oh, this table, I guess. Percent protein in each diet and the average SGR. Oh, okay. So the diet that resulted in the highest average SGR, which is 50.50, that's the highest average SGR. Also know they didn't have the highest protein. They didn't have the lowest protein S, which was the highest average SGR. Lowest average SGR had the highest protein. Lowest average SGR is Q, and they did have the highest protein. That's correct. C. Based on the results of experiment one, if experiment two were repeated, except that all the A per cooler were fed diet R, which would the average SGRs more likely have been lower or higher for each group? Based on the results of experiment one. Here's experiment one. If experiment two repeated, except that all the A per cooler were fed diet R, would the average SGRs more likely have been lower or higher for each group? Diet R. The procedures of experiment one were repeated, except that each group was kept at different stocking density, and all the fish were fed diet T. So diet T had a lower SGR than diet R. Oh, look at the reasons though. You know, I should look at there. Look at the reasons. Lower, low, high, high. But listen, on average, a per cooler diet, a per cooler fed diet R had an SGR 0.05% per day less than those. No, R didn't have less than T. R had an SGR. No, that's not right. It wasn't 0.10 less. On average, APR diet, fed diet R had an average SGR point zero 0.00 greater than those fed diet T, right? The diet SGR for R is 0.40, that's zero point 0.5 greater than the one fed T is that one. It wasn't 0.10, right? Because from 40.40 to 0.35 is 0.05. So you see, you didn't even, I was about to try to understand the question, but once I saw these lengthy answer choices, with all this detail and specific information, I could just check and see if these were true, and they weren't. The one, two, three, A, B, and D were not true. C was the only one true. That was the only reason. So I don't even know higher or lower. Doesn't matter though in this question. Sometimes it does, but not in this. Suppose that in the experiments, 1 gram of food were added to each tank at each feeding. A total of how many grams of food would have been placed into an individual tank each day? So in experiments, 1 gram of food were added to each tank at each feeding. How many times were they fed? So that's what you got to figure out, how many times they were fed in the experiments. So you got to read for this one, right? You're looking for how much they were fed. They fed a different diet. Each group was fed for 4 months. Each group was fed a different diet, and each group was fed the same mass of food 3 times daily. So 3 times a day, and every time they ate, they got 1 gram of food. That's 3 grams of food were added to each tank at each feeding. A total of how many grams of food would have been placed into an individual tank each day? Each day it would have been three. Yeah. Because they were fed 3 times, and you put in 1 gram of food at each feeding. How many apercula were placed in each of the tanks in experiment one? How many? How many apiculars? So each of 12 identical 15-liter tanks received 10 liters of water and submitted. Apicula of similar lengths were selected and the lengths were measured. They were equally diminished among the tanks. Tanks were then divided equally into 4 groups. You fed the same mass of food 3 times. At the end of 4 months, the length of each fish was measured. How do we know that? Average SGR per day. How do we know how many? They didn't say. Clownfish, two conducted diet. How many apricula were placed in each of the tanks in experiment one? Did I miss something? Oh, fish per liter. 12, each of 12 identical 15-liter tanks received 10 liters of seawater having a salinity of 33 parts. HMs. And pH was kept constant. Apricula of similar lengths were selected, and their lengths were measured with a ruler. Then they were equally distributed among the tanks at a stocking density of 1 fish per liter. So, and it was fish per liter, and they were 15-liter tanks. Wait, if it was 1 fish per liter and 12 identical 15-liter tanks received 10 liters of seawater. Oh, and it was 1 fish per liter, must have been of water, not of tank. So 10 liters of water. 1 fish per liter, that's 10 fish. Let's see. So you put 1 fish for every 1 liter of water you have. Since you got 10 liters of water, you put 10 fish in there. Hope you guys got that. Which of the following was a dependent variable in experiment one? Dependent means what you measured. Specific growth rate uh, was the dependent variable. The volume of seawater, you controlled that. That was independent. You determined that. You determined the diet. You determined the stocking density. You did not determine the growth rate. You measured the growth rate after you set all those independent variables in place, and you want to see what the fish would do. That's why specific growth rate is a dependent variable. It's dependent upon the other variables. Which of the samples in experiment one was most likely intended as a control for the concentration of vitamin C present in the unheated tomatoes? Oh, so we're onto a new thing, talking about tomatoes, because I'm about to say we weren't talking about that. Experiment one. So experiment one has table one and figure one. So which of the samples in experiment one, so our samples are on figure one, oh, and in table one, was most likely intended as a control for the concentration of vitamin C present in the unheated tomatoes? Has to be sample one because the incubation time was 0. It was not incubated. So we want to compare the incubation times to ones that were not. So said as a control for the concentration of vitamin C present in the unheated tomatoes. These also would be unheated because they weren't incubated at a certain temperature, right? Which means they're kind of warmed, right? So um, and they said the batch containing sample one was immediately frozen. Right, the batch containing two through four were each incubated in water bath. And then they were frozen. So this one was immediately frozen. We didn't put any heat on it. These were heated then frozen. All right. So yeah, sample one is the control. It's the thing that usually doesn't change while every other thing else changed, and you compare the things that change to the thing that doesn't change. Okay. Based on the results of experiment two there, which of the following incubation times? I don't see times here. I see lycopene concentration in different samples. Which following incubation times will most likely have produced a tomato mixture with a lycopene concentration between 5 and 6? So between 5 and 6 would be sample 3 or sample 4. What was the incubation times for sample 3 and 4? Sample 3 and 4 were 15 and 30 seconds. So 20 will work because 20 is somewhere in that range. Those wouldn't work. They soon claimed that heating tomatoes decreases the concentration of nutrients present. This claim is consistent with the results shown for which vitamin C and lycopene, if either. This claim is consistent with the results shown for which. So heating tomatoes decreases the vitamin C or the lycopene. So you added more heat as you went from 1 to 4. Did that decrease the vitamin C? It did, because the frozen ones had the highest concentration of vitamin C, and as you added more heat, went from 2 to 3 to 4, you got decreased vitamin C levels. So it did decrease vitamin C. So we know it's not lycopene only, and it's not neither. But now we took lycopene. And no, it did not. In fact, the lycopene concentration increased as you added more heat. Because remember, one didn't add heat to it, two did, three and four, and you increased the amount of heat. So as you increase the heat or the incubation time, um, then you did not decrease the lycopene. So it would be vitamin C only. Because as the heat increased, lycopene increased. But you see vitamin C as the heat increased. Vitamin C decreased, which was the claim they made. Assume that in the experiments, the water bath contained pure water at standard atmospheric pressure, 1 atm. While the bags containing the samples were being incubated, was the water in the water bath most likely boiling? Assume that in the experiments, the water bath contained pure water at standard, while the bags containing the samples were being incubated. Was the water in the water bath most likely boiling? Okay, so look at the reasons though. Boiling point of water. The incubation temperature was less than the boiling point of water. Greater than, so here's again, you got to know the boiling point of water. Degrees Celsius is easy. It's 100 degrees. So two things you gotta remember about degrees Celsius are easy. Freezing point is 0 degrees Celsius. Boiling point, which is also the melting point, right? Freezing, no, yeah. Freezing point, if you go from liquid to solid, that's 0 degrees is the freezing point. That's where water freezes at zero. But if you go from below zero up, then water would melt. So it's a freezing and melting point. But the boiling point of water is 100 degrees Celsius. Um, and no incubation temperature ever. The incubation temperature was 88 degrees. It did not cross 100 degrees. So it was not boiling because the incubation temperature was less than the boiling point of water. In experiment one, how many of the samples does that require background information? So we've come across a couple of them that do. Not many though. I wouldn't worry about those. Okay, in experiment one, how many of the samples had a vitamin C concentration of less than 1 umol per gram tomato? Had a vitamin concentration of less than 1 umol per gram tomato. They all had less than 1. All of them had less than 1.0. All right, that was pretty easy. All right, consider the following procedures performed in experiment two for sample two. The sample was froze. Consider the following procedures performed in experiment two for sample two. Okay. So experiment two is down here and sample two. It was not frozen. It was incubated in the water bath. Remember that about sample one was the only one that was frozen right away. Oh no, sample two was frozen. It was incubated first, then it was frozen. The sample was incubated in bath water, so we know two became before one. The sample solvent mixture was filtered. I think that's the last thing, so I think it's 213. I think it's C. I don't remember them talking about it being filtered though, so it must have been the last thing. Okay, okay, the mixture was divided into 4 equal parts. Each sample was placed in a plastic bag, and the bags were sealed. The bag contained one sample. Sample was immediately frozen. So they froze it. Oh no, wait. Experiment two, right? So they put it in the bath. We're talking about experiment two. They put it in the incubating water bath for 2 minutes. Then they froze it. 2 to 4 were incubated in water for a different period of time and then frozen. 2 days later, sample was thawed, and then 100 grams of sample was placed in a beaker containing, right, that was the last sample, and solvent mixture was filtered. Um, yeah, and then filtered using a what? Filtered, right. So that's the last thing. So yes, it was 213. A linear region of the graph is a range of data. Uh-oh. All right, we'll stop there because we passed the halfway point. And we'll pick up part two. We'll pick up with the rest. I just want to see that I don't want to tell you how many are left in this passage. Yeah, but we'll stop there and we'll pick up with part two of the science. Here's a doing in parts, so it's about an hour long. Because if I did the whole thing, you'd be a whole almost 2 hours. Where's the video? Oh, there it is.